Okay, so if we want to make a device which supplies 9 volts at a sufficient, 90 volts at a sufficient rate to be usable in a portable radio, and it needs to be portable itself too, then what are we really talking about here? Well, actually it is a kind of a power supply, but it's something which some people might say an up transformer or a step up power supply. So what are we really talking about? Well, we would need a sort of a battery pack. Yeah? We would need a battery. We would also need a circuit which would supply a B plus a heater voltage, a filament voltage, and then that would go to the radio. Now, basically, how does the step-up power supply really work, or at least how would we make it? Well, basically it would consist of 3 parts. You would need an oscillator. Yeah, you would need an oscillator. So that's the first part. The second part would be a transformer. And the reason why is simple to understand. The cheapest, easiest way to change one voltage to another is by making use of a transformer. That is why, for example, the mains voltage is AC. AC is quite easily how would I say changeable or transformable by making use of transformers. So you need an oscillator, and you need a transformer. So the transformer is the second part. The third part is really what would be, largely speaking, a rectifier bridge. You would need a rectifier bridge. Why? Because the voltage that comes out of the transformer, which would be higher voltage, of course, would need to be changed back to DC volts. Yes. So in comes DC voltage. Out goes DC voltage, 90 volts. Well, the input DC voltage can be theoretically anything you like. I'm thinking about using 9 volts. maybe 12 volts, I don't know, but it's not that critical. So our step-up transformer, so to speak, would really consist of an oscillator circuit, a physical transformer, and a rectifier bridge. So you would say, what's the big deal? I mean, you can make those three things, or you can buy those three things off the shelf, and there you go. Well, it's not entirely that simple. Some of you might even say, you don't need all of this. You can buy a switchable power supply, which would somehow, transform the voltage with a voltage doubler circuit, with capacitors and rectifiers, diodes, in other words. So you would have a circuit like this, but etc., etc., etc. You would have something like this, but we're not going to use this because this provides too little current, really. Let me see how to tell you. You probably know, or you probably suspect that I am going to build this. Why? Well, because it's fun, because it's useful to me, and if I can make a prototype that works, I can make a permanent one afterwards in the shape of a battery, of an original, say, ever-ready battery, and then use it in any portable radio, tube radio I will repair later on. Now, what are the requirements? Well, the requirement at this stage is this. I need 90 volts B plus and 1.5 volts filament, and I need, for the B plus voltage, I need around about 20 milliamps of current, and for the filament a maximum 125 milliamps. If my power supply can generate this type of power, then I think I can make a power supply which would last, say 2 or 3 hours continuous play with the radio, continuous listening to the radio. And by the way, a third requirement would be that it should be rechargeable. And a fourth and last requirement would be that the size stays smaller or is equal to the size of a battery. Alright, so there you go. That is what I need to find out. How can we make a circuit which looks in its most simplest form, in its most schematic form, like this, to provide me with this? And the answer is, well, you start with the essential part first, and this is part of it. So it's a breadboard, like some of you will probably have used before, with a tiny power supply here and a small circuit here. And the small circuit you see on here, and in fact the essential part of the circuit is the upper half of the breadboard, is an oscillator. And this oscillator is something most people who do electronics will certainly know. Its technical name is an astable multi-vibrator. An astable multi-vibrator, or in much simpler terms, a square wave oscillator. So I will take this as a basis for the first part of my portable power supply, namely this part. Now you'll notice that AC voltage, when we speak about AC voltage, we often speak about sinusoidal power, or voltage, and not so much about square shaped voltage. But no worries, you'll see as I go along how I tackle that point too, and you'll understand why I want to tackle that point too. Unfortunately, to understand certain steps that will be needed to build this sort of thing, there will be a little bit of maths involved, but I'll try to keep the maths as simple as possible, and I'll try to show you the practical results of the math instead of doing all sorts of mathematical computations on paper or on computer or whatever. So don't worry, I won't flood you with all sorts of mathematical formulas, but I will have to show you a few calculations to make you understand what I'm trying to do. To finish it off, I want to show you what this oscillator generates as it stands right now. So there you have the oscilloscope, and now I switch on the oscillator, and as you can see, it generates square waves. But if you look closely, you'll notice that the square waves are not perfect square waves. In fact, they are a little bit rounded, and that too can be explained. There is some how should I say it? There is some maths behind this, but I'll try to explain it in the next video without all the maths involved, and I'm pretty certain you'll understand. So stay tuned for the next episode of making the Technemoira DynoBat. Until then, bye!